Right. Hi there. Welcome to another live stream. In today's live stream, I'm actually going to be working with Blender, and I've just dusted off a project I had from some time ago, like a few months ago. I was working on. The idea was basically I wanted to visualize a model in a TensorFlow model in using Blender, and I've created a bunch of code, right? I got stuck somewhere. I'll explain you where I got stuck, but you know, I've done fairly good progress, right, in this code. So I have some Python code here that is trying to visualize how a prediction is done on a neural network. This is, I'll just give you a background. So if I show you this picture, so this is the, so some time ago in the channel, I did a video about an image, like a TensorFlow model that does image classification, right? And I've, yeah, I hope you can still hear me. My microphone has some issues, so let me know if you can't hear me anymore. So the idea is this image classification model is able to look at a painting and decide whether this is a painting about the nativity of Jesus or not. Okay, so that's what this model does. Okay, and what I have here, I have some Python code, okay, that actually trains the model. You know, I've installed TensorFlow inside the Blender for this, and then it trains the model, and then I basically have a model.predict here. I can't do a search here for some reason. What is it? So we have train model. Okay, this is a visualized model. So in this method, I basically do a prediction on this image I just showed you, okay, to find out whether it's able to predict that it's an image of a nativity or not. Okay, and then what we do, we extract all the neural network layers, right? So the idea is this extractor will, instead of just giving like a result. Thank you so much. Okay, thanks for the feedback. Yeah, yeah. So this model has like a bunch of. Well, I might as well show you, right, what I'm talking about, because I have it here. Geometry node, texture paint. So I'm not like an expertise of Blender, so you know, right? But I know enough that I was able to do something cool with it. So you can see here, this is like a draft version of the neural network. You can see the layers. So this is representing a rescaling, which is what basically the model, when it gets an image, you will rescale it to a smaller size. Okay, and then you have here a bunch of, you can see, oh, it's a bit, sorry, this is not finished by any means, right? So I don't even know, I didn't even put the labels properly yet. Okay, so you can see here. This is a 3D view of the neural network. Okay, so we can see here the rescaling layer, right? Then we have a convolution 2D, which is a bunch of filters we apply, you can already see these images here, right? These are like the results of applying a filter. So a convolution, a 2D convolution will normally apply filters and to try and identify, in order to identify features. And that's why you see here different types of, you see like, this is the same image, but with different shading, right? And different highlights. A filter, by the way, when you apply a filter, it loses the color, right? It becomes like one channel only. So this is actually grayscale, okay? And okay, so we have a bunch of, we have a convolution, we have a max pooling, convolution, max pooling, convolution, max pooling, and then a dropout. The dropout is basically just losing connections, okay? And where I got stuck is that at some point it flattens the whole thing. So it takes all these images and it flattens it. And then we, instead of just having like a few dozen like images here, then we have thousands and thousands and thousands of neurons. And I got stuck because I was trying to create like this massive array of neurons. And then the problem is not even creating the array of neurons. You can create thousands of neurons in, they're just spheres at the end of the day. In Blender, you can just create one sphere and then you can repeat it n times. You can do that with geometry nodes, or you can do that with Python. Okay, the problem was more where I got stuck was trying to connect these spheres together. And also, I had a problem because I was trying to create the spheres. Well, actually, I was trying to create them one by one and using a very inefficient function, so it was hanging my computer. Right, so today I have to be very careful because if I do the wrong thing here in Blender, it's going to hang my computer and then my live stream might go down as well. Which is not fun. But yeah, so my goal is to try and visualize the neural network and show the predictions, create an animation, and then instead of just having one input image, then I want to have like many input images. Okay, so if we look at the code, some of this code I don't even remember anymore because I wrote it months ago. So yeah, this is very much like in this live stream I kind of want to pick up this project. It's not just about showing, to be honest, it's more about trying to see if I can get myself unstuck and do something more interesting. Right, so I have like here several if statements. This one is for the max pooling. Yeah, and then I have one for the dropout, and then one for the convolution 2D. The convolution has filters, okay? So each image you see in that layer, it's the result of applying a filter. And then flatten is basically just this massive, it basically takes every single byte of the image, right? Of all the filters together, right? And then it makes it one big string of neurons, like, and that's why it's called flatten. I try to represent that in different ways, and I'm going to open, I'm going to close this project, okay? Maybe I'll save it so I can, anyway, so I'm going to open a new one. And to be honest, like this code for now, I'm going to leave it, and I'm going to try and do something simpler with not, you know, with maybe a, okay, let me just show you first of all the attempts I've done in the past, okay, to try and represent these flattened neurons. And then you'll see, this is actually me learning how to use particle systems. So I try to, I think I've done it, I've tried quite a lot of things actually. So I've tried to create this using geometry nodes actually. You can repeat things. But I don't think that was my best result. That was just like a tutorial I did maybe just to understand how that worked. And then I have particle. I even tried, Oh yeah, this is the particles example, right? I've tried this as well. Yeah, but this is probably not the best I can do. And I tried as well, neural network with array modifier. I don't even remember what this is anymore. Okay, this is the kind of what I'm trying to get to. This is a massive array of like neurons, right? This is just one layer, right? So the Flatten creates as many neurons as this in one layer, but then you have another layer, which is where the dense layer is, right? The dense layer is basically the part of the neural network where you already have to. It's basically going to give you the answers, right? So you have like 2 or 3 neurons, depending how complex, how many classes you are trying to identify. In my case, for this model was 2, so it's like yes or no, and so it's 2 neurons. So you need to basically, for each of these neurons, you need to create connections to the next layer. Yeah, something like that. So each neuron needs to be connected to one of the neurons, to both the neurons in a dense layer, and then you have the weights. The weights will determine how thick the connection is. So that's what I really want to try and do, to try and draw that. So, but to be honest, I've realized, okay, if I start with this massive scale, it's very hard to understand what's going on. So I'm going to try and start from scratch again for this, okay? So, okay, and forget about geometry nodes, yeah? I want to do this with Python. I'm pretty sure I have done this with Python. So, and with Python, you can also use an array repeater or something like that. Is it this one? Yeah. This one. Oh, this is Python, version of Python I've done. Okay, so let me see. I hope this doesn't break my computer. 1 second. If you have any questions, let me know. And if you're an expert in Blender, let me know as well. I'll be happy to hear any opinion, because this is very much, yeah, something I'm trying to figure out. All right, so what do I have here? This is like code I haven't seen in months, so forgive me for not actually remembering what this is. Okay, so I have number of nodes, 100 and 100. Okay, I was trying to do something with this, right? 12, 12, 100 and 100. And let me see if I manage to... Oh, so I have something here, right? Look. So I'm trying to do... Okay, so I have... But you see, I can make this much smaller, so it's a lot easier to try and get. Okay, so this is what I have already. So 2 layers. So I need to create connections from this layer to that layer. Yeah. So I think my computer is starting to struggle because this is too many. So I'm going to delete all of them. And I'm going to try and use like 10 at a time. Maybe just make it much smaller. Yeah, so it's fun, right? So can you hear me properly? Because I think my Blender is going to take me sometimes offline if I do the wrong thing. So let me know if, yeah, if it's not working properly. And anyway, what I'm going to do now, I'm going to try and simplify my life, make this as small as possible. So I'm going to reduce the number of neurons. It doesn't really matter how big your problem is. If you can solve it for a smaller set, then you have a good chance to do it for thousands of neurons. But the problem will always be performance, right? And I only have 1 GPU, so if I press the wrong button, then it's going to take my computer down. Okay. Okay, cool. Thank you. All right, so screen. Okay, so let's see. Okay, so now we have less neurons, right? This is much easier. Okay, right. So I've managed to write some code. So I have 22 by 22. So that means, okay, so I'm going to make it even smaller. So it's just like very, very easy. So I'm going to make it 10 by 10. And then, oh, even this is struggling a little bit. 10. Okay, no, 5. 5. Okay, 5. And then 2. 2 by 2. So let's try again. I think I need to delete the previous ones. Okay. All right, so I have, okay, so this is the easiest you can do, right? So imagine this is thousands. Okay, this is only like 5 by 5, so 25 neurons. And then we have 4 neurons, right? And what I'm going to try and do, I'm going to try and create a connection. So this neuron needs to be connected to this one, right? And then to this one, and to this one, and to this one. And then what's going to be different is going to be the thickness, okay? So I'm going to try and do that. I'll figure out how to do that. And then I have this method already. All these methods are inefficient, actually. Maybe except for I'm using an array modifier, so that's actually not too bad. So I'm going to try and create a cylinder, okay? So cylinder, I think, so a cylinder, I can do it via here, and I can figure out what is the actual method call that it's making. Yeah, exactly. That's correct. Yeah, fully connected layer that I'm trying to do. The cylinder. So mesh. So the idea would be to represent. Oh. So we just go to modeling. You see this cylinder? I'm going to make this very thin. It doesn't even have to be a cylinder. It could be just like a cube or something. No, not a cube, like a rectangular, a cubic shape, right? But right now, this is probably the nicest in terms of. So if let me just try and do scaling. Yeah, you can do scaling in Blender, right? This is manual for now, but I'm just trying to give you an idea of what I'm trying to do. So, and I don't even remember all the shortcuts anymore. But I think, okay, S is for scale. And then I have to try and move this, which is to rotate, I think. Rotate, yeah. And then you can specify the axis you want, like X, then Y, or Z. Yeah. And if I do this, so the idea is, this is massive, but okay, if I just do on one axis or both, you know what I mean? Okay, you get the pictures, right? So I'm not going to try and make it by hand because this is all going to be done via code. So I'm going to try and create a function that, given a cylinder, sorry, not a cylinder, 2 spheres, you will connect them with the cone, or whatever. What was it called? A cylinder, yeah, a cylinder. Right. Okay, so wish me luck on that. So the actual cool thing is that I already have at least one function that does it. By looking here, I should be able to see which function I can use. Script. Just going through the list of commands I've done. Okay, you see this one? So this is the function I want. So I'm going to copy this. This is the function. So we have bpy.ops.mesh primitive cylinder add. Then I can specify the radius, the depth. I don't think I need to specify all these parameters, right? I can remove them. Yeah. And align, yeah, don't need that for now. And then scale. So if what I'm going to do, I'm going to comment out this code for now. I'm going to try and run this. So let's say depth, let's do 100. Radius, make it as thin as possible, like 0.1. And then location, yeah, it doesn't matter for now. Scale 111. So the scale will allow me to make it. Oh, the depth is how. It's probably the z-axis depth. Okay, let me just try it. So you can see, let me try and use more space here on my screen. You can. Right. So you can see here, right, a big. Go to this side. Okay, you see here, this is my cylinder. So the depth is already making a difference, right? Okay, the thing is, right, it doesn't really allow me. I want to create a function that given 2 coordinates, right? So maybe I can create a function, definition, connect. Let's call it connect, right? Connect the neurons. And I'm going to pass in a location start, yeah? And then a location end. And then I'm going to try and use this method here. Pretend that the neurons are already there. So I'm going to just, okay, for now the radius, I'll leave it like it is now. Depth, I think this will be based on, so this depth, I guess it will be 50-50, like 50 above 0 and 50 below 0. I can actually see where it is. So if I go to, like, actually there should be something like N. If I press N in the keyboard, it tells me the dimensions. So you can see it's 100 meters. That's probably a bit big. It's quite big, but it doesn't matter. Like, forget about the fact it's meters. It could be millimeters or whatever. But I can see that the lowest. So that's the dimension, and then it doesn't tell me what's the lowest and highest Z value, but it should be -50, I think. I can find out. So let's try here. Look. So Z -50, yeah. Okay. So depth is, yeah, you can consider that like the distance, yeah, between the two neurons. Because I'm going to be using, so this is going to be connecting the two neurons. And if I, yeah, so basically, I take this one here, this is one neuron, and this is the other neuron. So the distance between this one and this one is basically is going to have to be the length of our connection, right? Yes. So, but I don't think I want to specify the depth, because if I have to specify the depth, then I have to calculate how big, you know, depending on the angle, it's going to be a bit more tricky, right? So I would rather specify the location of this and the location of that, and then let Blender figure out all the maths. But I'm not sure whether I have the option. I'll see. So there's a location. I think it only allows me to specify. Oh, let's see. But I'm sure I can figure out. One second. So I'm just going to go to the API and have a look. See if there is anything that makes it easier. Yeah, distance. Yes. All right, so... Okay. So APIs. I might have to do some mathematics here, which I didn't want to do this late in the night, but you know. Oh, did I close it again? So, okay. So mesh operators. Let's go to the API first. I think the Blender documentation, at least the last time I checked, is very good in terms of detail of APIs, but it's not great for like examples. Maybe they've improved it now. We'll see. Okay, so what do we have here? Okay, cylinder. Cylinder, yeah, this one. Okay, so we have the radius, okay, and the depth, and there's a location, rotation, and so on. Okay, and there's no like, they're not making my life easy, because it seems like they only give you like that location, like the center of the cylinder. Okay, so I need to, I think I can do that, because the distance between 2 points is basically my depth anyway. So let me just do this distance. It's like, I still, oh, even a distance of 2 is like the square root of, it's like the vector. Okay, so distance between 2 points, I remember vaguely that it's like between 2 coordinates. It's going to be the square root of something. Maths. Let's go back to maths. It's very simple one, but you know, it's not something I do every day at work. So distance, this is the XY distance, right? But the XYZ distance is probably going to be A squared plus B squared plus C squared, right? Hang on, wait. So we do the vector first, right? And then we do this. Oh no, this is using the triangular. Okay, this is different. Okay, not this one. I want 3 coordinates. Okay, let's do 3D. Going back to basics. All right, this is like, so this is for the XY, for the 2D. So basically difference between the 2 points X and then Y and then Z. That will be for 3 points, yeah, for 3 coordinates. Yeah. Okay, right. Let me implement that. So I'm sure there will be somewhere in the Blender Python API something that does that as well. So let me distance between 2 points. But it's actually very simple. I don't even have to. Let me do the. I will do the formula and then I'll find if there's an API already available. Because I'd rather use an API rather than implementing everything again, even if it's that simple. So distance between 2 points. This is actually the fun part, right? This is like the Python that we. Okay, so location 1 and location 2. Okay, so X, Y, and then Z equal to location 1, and then we have X2, Y2, Z1, Z2 equal to location 2, right? So the formula says the distance equal to, okay, it's first of all we need to calculate the difference between the 2 vectors. Equal to, okay, so x2 minus x1 plus, okay, I'll do a square. I think that I'll have to use the math functions later. I'll put for now like this. So x2 minus x1 plus y2 minus y1, and then plus z2 minus z1. Yeah. And then it will be the square root of these. Okay. In Python, there should be some maths APIs I can use. So let me find again. So Python maths API. So let's do. First one we want is the square. Where exponent. Okay, we can also use exponent function, which is the same as, but this is not. Okay, so this is an option. Okay, not this one. Square. This is square root, but I want. Oh, it was something like this. Oh yeah, okay. So this is the coordinates. So this is how to do in Python. So we just have to go do this basically. 2, 2, and then 2. Okay. And then math the square root of the result. Yeah. Then return distance. But I think I need to also make sure that we don't have any, because in Blender, right, you can't just have like fractional coordinates. You have to have whole integers, I think. Yeah, I'm pretty sure it's the case, but before I do anything with this, I'm just going to test the function. So distance between, I don't know, 0, 0, 0, and 1, 1, 1. That's the simple scenario first. And then I'm going to do a distance and then print it. I'm not doing, so let's do that. So Python failed. But, okay, so the system console, you can see it from here. In a Mac, it's a different business altogether. If you want to see the system console, you need to start from the terminal Blender. But in Windows, we have a little bit of, this is a bit of a perk in Windows. You get it. Okay, so name math is not defined because I have to import math. I'm going to add it here, import math. And I'm going to run this again. And yes, it worked. So let me find the system console again, because that's where I printed my message. Okay, so it's actually calculating the distance as this. Yeah, I think it makes sense, right? No, but hang on. So 1 minus 0, yeah, is 1. And then plus 1, 3, and then a square root of that, basically. Okay. I think that makes sense, right? So does the depth accept if I give it like 100.5? Or do I have to round the number? We'll find out if we have to round the number, right? So this is something I don't know yet. So let's find out. Okay, so I'm going to give this location and this location. So I'm going to test this. So distance. Okay, so first of all, I calculate the distance between. Oh, what did I do? Distance between location start and location end. Yeah, and then I pass this distance to the depth. But I'm sure it's going to tell me, oh, you can't do that. You need to round this to an inch here. But for now, I'm just doing it to make it fail. Oh, I can also check the API. But I'm pretty sure it's going to be a, I don't know. We'll see. Let me see. The API will tell me, actually, if I want to be precise, I can just check the API. So the API tells me that depth is actually a float, so it actually accepts a fractional number, so it's okay. So depth. So location. So how do we do location? Because okay, so we have, this is not like the location of the start of the cylinder, it's almost like the location of the middle of the cylinder, right? So I need to work it out as well. Let me see if there is any other option. So location, optional. Float array of 3 items in minus inf. Oh wait. Yeah, it's going to be the center of gravity, basically. So let me just figure this out then. going to mod geometry nodes. From here it's easier. So if I, so the point, the location is actually this one in the middle, right? So if I want this location, and basically I want to specify this location and this location, but I only have the option to do that in the middle. So I need to find the point in the middle between the two locations, right? Interesting. Okay, so what do I do? Do I just like do the difference between the 2 points and then just divide it by 2? All right, okay. Nice to meet you, Mustafa, and yes, have a good work meeting here. All right, so we have here, okay, so we have the start and the end. So how to find the middle point, right? My kind of intuition tells me if I want the middle point between location 1 and location 2, I just have to do the difference between the two locations and then divide it by 2. I can do that and just see what happens, or I can also do a little bit of a search and find out. That's about geometry. Difference between 2, finding the point, the middle point between 2 points. This is on the circle, but I don't want in. Interesting. Okay, so let's see if my intuition was right. So the distance, we already know how to calculate that. And then to find the middle point, yes, as we... Okay, this one. Oh, interesting. It's a sum rather than a difference. Okay, I wasn't expecting that. I think I've forgotten a lot about geometry. So what it's telling me is that, okay, so I need to, okay, so we have the distance. So distance comes here, and then midpoint. Oh, I will call it midpoint, sorry for the lack of imagination on the names, but midpoint is equal to, okay, I can also create a function for that. Calculate midpoint. Yeah, I'm going to call it midpoint. Okay, so imagining that I already have it, right? So midpoint will be passed in as the location. Okay. Then we have the depth is a distance. And then the radius, okay, for now it's just a fixed value. And then the scale, this is something that you could use this instead of, hang on, let me think. Yeah, the scale is a way to adjust like the length and the width. The depth, I guess, allows you to specify how tall you want the cylinder to be. And then this one allows you to adjust that, like how thick, how, and other things. Yeah. All right, so now, okay, so I already have this. I need to create a function, obviously. So midpoint, location 1, location 2. is equal to, so midpoint. So let's do the same thing we do here. Then we just do x1 plus x2, okay, divided by, okay, so we can make it x12 equal to x1 plus x2 divided by 2, okay. And I need to figure out, okay, I know coordinates, they need to be, do they actually? I don't think so actually. I'm not sure whether Blender accepts fractional coordinates as well. I think it might do that. So I'm going to assume it's going to be a float for now. Okay, so if it's a float, I can just make it, I don't have to worry too much about rounding it. Okay. And now we have x1, x2, then we have y1, y2. And then we have z1, 2. Okay. This is going to be interesting to see if all these maps will get us the right the right answer. Okay, so we have now, so basically I just return x1, 2, y1, 2, and then z1, 2. Yeah. And we have the midpoint. Yeah. So midpoint. Midpoint we have, okay, so what am I doing here? Okay, yeah, we already have the function. I need to make sure I declare this before I use it. In general, it's better. I think it, yeah. Right, so if I run this, it's nothing yet. Oh, did I make a mistake? Yeah. I think I might have done a mistake. What did I do wrong? Oh, I hope I saved it. Hang on, I didn't even. I don't know what I did wrong in Blender, but it's not looking good. I'll take a screenshot of my code because I might lose it. Yeah. I have a screenshot now. So, this is the dreaded moment where you realize, okay, I might not have saved all that I had written, all this beautiful code, and if I just say close the program, it's probably going to be a loss. But I've taken a screenshot, don't worry. To be honest, this code is not that much. I'm just going to bite the bullet. And I have to figure out what I did wrong there, because it didn't look, I don't know what I did wrong. It looks fine. It's just adding I was just dividing numbers. Okay, so it's fingers crossed. Open recent, yeah, I think this one. Oh no, it's okay, I have a screenshot, but like I'm a little bit upset, to be honest. Make sure you took note. Yeah, let's do this. This is not that difficult, right? But this, I'm going to put this to the side so I can actually read it. and write it down. But this should take me 2 minutes. So, and then I have to figure out what I wrote there that shouldn't, that crashed this. And I'll save it before I even run it, to be honest. Okay, midpoint, location 1, then location 2, and we have x1, y1, z1, and then location 1. Then we have x2, y2, z2, location 2. And then, oh, oh yeah, of course. So now the midpoint is x12 equal to x1 plus y1, then divided by 2. There's nothing wrong with that. I don't know why it crashed. So y12 equal to y1 plus y2 divided by 2. And then we have z12 equal to z1 minus z2 divided by 2. Okay. And then return x12, y12, and then z12. Okay, right, so this is one of the methods, and I'm going to try and test this. I don't know why it doesn't let me indent this properly. In Python, you need to make sure all these lines start in the same column, otherwise it's going to crash. No, it's not going to crash. It's just going to give an error. But with Blender, you never know. Okay, I'm going to save it now. Look. Saved. And I'm going to just do a print. So midpoint of, let's do something simple, right? Something that we actually know. So 0. Oh, I'm pressing 0. It just goes back to the beginning of the line. So 0, 0, 0. Then 1, 1, 1. So the midpoint of that, right? I think we all know that. It's I don't even have to do maths for that. Let's just write it down. Let's print it on the screen and hope this doesn't crash. What did I do wrong? Line 89. I might have forgotten to close some brackets. Or, yeah. Yeah, I did. Yeah, okay. So let's do this. Python script failed. Let's see the system console. Okay, so we have Python script failed. They gave me the right answer, to be honest. Well, kind of. This is not. No, this is actually not an error. This is okay. But why did they give me? Why did they give me a negative number? I wasn't expecting that. I must have done something wrong here. Right? Oh, I did the minus. Okay, so it should be a plus. So it's good always to double check the basics. I should even do the unit test, but I don't want to bore you. Okay, so okay, now it's correct, right? So this is what we expect, except for the first one, right? The first one should also be 0.5. Oh, I made a mistake here as well. My code is full of bugs. So x2. So x1 plus x2. Yeah. No wonder my Blender crashed. Right, so next. So we have, now it's correct. So the basics are fine. So this is a midpoint for something very simple. So I'm actually hoping it should work for anything more complex than that. Right, so now we have the midpoint. Now I need to write the distance function, which I lost as well. Make sure I save this first. So distance between location 1 and location 2 is, yeah, I'm going to copy and paste this. We have, okay, so the distance will be the mathematical formula. So distance equal to math dot square root, and then we have x2 minus x1, and then we have this is to square, then we have plus, then we have y2 minus y1, and I'm going to do this like that. So y2 minus y1, and then z2 minus z1. Okay, and then we have to close the brackets, and that should be the distance. Then I return the distance. Okay, and I'm going to try and test this as well before I even try to do anything more complicated with this. So distance, so what should be the distance between these two? A good point. I think it's some kind of, it's not as straightforward as it seems. Not in the 3D space, at least. But it should be like square root of 3, I think. Okay, so we have 2 saved like 10 times already. And now, let's see what... Okay. I need to import math. So import math. And now, let's run again. Where's here? Okay, so we have 1.73. Looks okay. Right. Okay, so we have the distance and the midpoint function working, and now it's time to go back to that connectNeurons function that I lost as well. I don't know why, to be honest. I really don't know what I did wrong there. So definition of connectNeurons, location start, location end, and then distance equal to distance of location start, and then location end, and then we have the midpoint as well. So midpoint, or maybe midpoint equal to midpoint location start and location end, right? Okay, so we have both these two, and then I can just create my bpy.ops.mesh.primitive cylinder add, then radius equal to 0.1, depth equal to distance, and then location equal to midpoint, and then scale equal to 1, 1, 1. Right. We have Okay, so we have that, and yeah, so it should do what I want. I'm going to save it again, just in case, and I'm going to connect to the neuron. I'm going to just randomly call this for like the same range that we. So for this basically. Yeah, so I'm going to call it for this very simple points and hope this doesn't crash. Okay, 1, 2, 3. Okay, did it fail? Let me just see if there's any error in the console. connectNeurons is not defined. Oh, I've added the M instead of an N. Okay, let me try again. Fingers crossed. What happened there? So there's no error. Let's see. So modeling, or where do I go? Yeah, 1 second. I still have these guys here. I probably want to delete them. Second. Yeah, too big for what I'm trying to do right now. Okay, so you see, so I have my cylinder here, but I don't know if the coordinates are correct actually. Okay, so the location is the midpoint. Okay. Z dimension. Oh, okay. Interesting, because I think I made a mistake, right? I made a mistake here because I thought we're talking about the distance between the 2 points, but actually this is different because I need to rotate this, right? It's not actually. Okay, let me just find the easy way to explain what I'm trying to say, but I'm not going to use Blender because sometimes the draw.io I use that and it's easier. So let me see, save. Save it. So bear with me a second. Right. Okay, so I have here like a diagram. Yeah. Well, I'm just trying to. Okay, let me. Okay, there was. So I'm going to try and draw something here, right? So this is my neuron, right? It's funny that I'm actually not using Blender for this, but never mind. So Control C, Control V. I'll just do another one. Okay. Yeah. So the coordinates was. So this is like trying to do the X, Y, and Z coordinates just for. X, then Y, and then Z. Okay, so we have, right, and then we have the neurons, right? So the neuron is in coordinates 1, 1, 1. 1, so 1, 1, 1. Okay. So the cylinder, I'm not sure how I'm going to do a cylinder here, but it doesn't matter. It doesn't have to be accurate, right? You get the point. So let's do a rotation. You see, I had to create, oh, what a mess. Okay. Maybe an arrow is a better. It's just a line. I just want a line. Line without anything. Okay. Doesn't matter. You see? So this is the depth that I just picked, right? That's the distance. But the problem is I've put the distance in the Z axis, right? So it looks like it's wrong, but it's actually right. I just need to rotate. I just need to rotate the cylinder here to match, to basically start exactly where I want it to start. It shouldn't be. Anyway, it's not as easy as it seemed at the beginning, right? But if I show you the coordinates here, I can try one of these. So minus, basically I have to rotate. I'm going to do it by hand just to show you what I mean. Okay, so rotate like this. Z, X, and Y. Okay. Sorry, I didn't want to. Anyway, the rotation. Yeah, like this. Yeah, roughly, just to give a point. So this is hopefully like 1, 1, 1. So basically the idea is you create a cylinder, it's going to be in the vertical, and then we basically rotate it so it basically falls into place. Knowing how this works, right? The mid coordinates is the point that we are providing. So we need to first shift the cylinder up, right? And then we need to move it. We need to do we need to bend it. Okay, let me see. I'm sure that would be an easier way, but you know, this is like, it's one attempt, and then you can always optimize and make it smarter. Where's the scripting? I think I had it somewhere. Scripting, yeah, it's here. All right, scripting. Okay, so I'm going to, okay, the depth here, the location, I'm actually giving the location of the midpoint. Okay. That actually doesn't, hang on. So if I'm giving the location of the midpoint, I don't have to shift it, I just have to rotate it. And let me just see how to rotate. So in Blender, okay, for now I'm just going to use all the Blender functions without worrying too much about performance, you know, we can replace that on another session. So right now I'm just going to find where the rotation function is. Okay. Oh. Okay, transform rotate, yeah, this one. So I'm going to copy it. This is going to use the active object, if I'm not mistaken. So the value here is probably going to be some radians. We can always convert this from degrees into radians. Okay. Wow, it's starting to get more complicated, the maths, but... And I'm starting to sweat a lot. It's supposed to be so simple, something to connect, but it's actually a bit... It requires all the maths. Right, I want just API for now. Give me just API, I'm happy with that. API, okay, so API, rotate. So we have like a huge number of arguments, but I'm pretty sure that I can remove most of the arguments just down to the ones I actually need. But to be honest, okay, the value here, this is the angle. It's probably in radians. And then we have to figure out like, okay, there's functions in Blender, sorry, in Python maths. Okay, so the Python already has functions to convert radians to like to degrees. Yeah, let me just find which ones they are, because I function more with degrees. A radian is, I think a radian comes from circles anyway. That's where the... Okay, dot radians. We convert. Okay, so we have a function here to convert an angle in degrees to radians. So if I want to use that, I will use it. If I need to use it, I will. I have it here. Okay, so, but the next thing I want to figure out is the maths first. Because, okay, so I know my cylinder is going to be like, you know, facing up in the Z plane, so. So let me just draw. Okay, this is a better one. So you see this is the cylinder, right? Yeah, and then we have to basically, see, there's an angle between the cylinder and the actual position. So there's an angle here between here and here. Yeah. So this is the angle I need to figure out, so that we have, so once I know what the angle is, I know how much I have to rotate the cylinder. And I think the rotation only needs to be done on the, yeah, it needs to be done on X, Y, Z plane. So yeah. So let me think. Yeah, I've actually done this before. It's just don't want to just go and copy code. That'll be so. It'll be bailing out. Okay. But the easiest way, okay, this is the 3 plane, is to figure out in the 2 plane first, and then we can translate this into the Z plane. We know the cylinder is on this Z axis, so we need to just move, and our point is here. And we have So this is basically so the vector. So I know how to create a vector, and then I can use the vector to basically determine the angle between that vector and the z-axis vector. So if I can do the vector between the two, I can calculate the angle. And if I have two vectors, I can calculate the angles between two vectors. It's the cosine. Yeah. I think I know where this is going. So how to calculate angle between two vectors. Okay. And the thing is, there's an angle in 3D. Okay. So it's not as simple as it seems, right? Okay, let's see. So this is starting to get more serious maths, just for something that seemed so simple. Right, start with the basic, okay, dot product. I just want to answer. I don't want to go through all the explanation. Not at this time of the night. Okay, if vectors A and B, then, okay, this is it. It's my solution. But then, okay. We have a potential answer. I need to figure out how this method works. So value equal to 0 is the angle. And then we have to specify on which axis we want it to move. So I was thinking both. Okay. I'm sure Blender has some functions here. Let me see. Python, calculate. I'm pretty sure there's something in Python to do this. Angle between two tuples. This is a numpy. Yeah, let's do this, yeah. So I'm bailing out. I don't want to be creating the form myself because it's too many tangents in one. Okay. Think. Okay, this is probably the wrong answer, so I need to go to the green tick. Okay, here. Oh, this is not. Okay, so it's created the. This is X and Y only. I want X, Y, Z. Angle effector, A, B, C, D. This is for. Okay, maybe I should just try and fix it, get this to work. Okay. So let me just make this bigger and wish me luck. So, okay, so arc cosine of. So these are the vectors, right? This is what we need. Then we have to do XA plus XB plus YA plus times YB. Sorry, it's not plus, it's Y, it's times. Okay. This is, I don't know what this is square brackets, I guess this is for the function. It's a lot of, what's this sign here? It's a square root, I guess. It must be a square root, yeah, okay. All right, this is easy. Okay, so I'm going to try and do one at a time. So the first one is this one. So I'm going to define another function called angle determine angle. So vector 1 and then vector 2. Okay, and then we specify. So let me just do XA, YA, ZA equal, I don't even have to have brackets, but I'm doing it anyway. I don't know why. So vector 1 or vector A is just to be more. And vector B. XA, YA, ZA, and then we have XB, YB, and ZB. And we have vector B. Okay, and now this should make more sense. So angle, I'm going to have to divide this in, this is dot product, right? Or something like that. I'm going to give names to it. So dot product between the two vectors, and then we have a division. Okay, and then we have this, which is so square root of this, and then this one. Okay, so this is basically, okay, square root times the square root. Okay, I'm just going to call it square root of vector A, something like that for now. And then I'm just going to do XA square plus XB square. No, not XB, right? So YB. No, YA, sorry. YA, and then we have ZA. This is starting to get worse and worse. It's only a simple function, right? To go from A to B, and I'm already doing all of these maths. But I'm sure Blender already implemented it. I just can't find it right now. I'll find it at some point or offline. It's all about knowing the API as well. But the maths is fine as well. So we have here, okay, square of vector A. And then we have math.sqrt. And then I'll put, yeah, like that. Copy and paste, you have to love it, because otherwise it becomes too. So square of vector A, square root of vector B. Yeah. And if I look at this formula, it's doing a division. Okay, now this is first the multiplying the two. Hello. Hi Dark Matter. I think you mean hello, not hell, right? Because yeah, I am in a math hell right now, but I'm not sure whether that's what you're referring to. Okay, so now arc cosine. So I need to find this function as well. So product. I'm just going to call it product sqrt equal to Okay, so dark matter. Yeah, sorry if you're out of context. I have a project from the past, which I was trying to visualize a neural network in Blender. Okay, I've abandoned it a long time ago, and I just decided to go back to it. And yeah, if you want to see how, yeah, you probably have to go back to the beginning of the stream, and you'll see what I'm up to. But basically, the idea is to visualize a neural network and show it how it looks like, you know, in Blender in 3D. But I'm also doing some fun mathematics and geometry here, which is awesome. Arc cosine, let's see. Oh, arc cosine, yeah, this one, yeah. You have to love Python in terms of maths, right? That shouldn't be a problem. Okay, so let's see. Okay, math.acos. Okay, so I have here the function I need for later. Yeah, it's fun. Yeah. So square root of vector A times square root of vector B. And then we have to do a division. So that's okay, right? So then I have to divide this by this, and then I have to apply arc cosine just to get an angle. Okay, where I was, okay, so dot product, so angle equal to dot product divided by product of sqrt, and then we have to do math.acos of this. And to be honest, I haven't really checked. I think everything is going to be a float, right? Like a fractional number, so it should all work at the end. But I need to just bear in mind that things might not be what I expect. And this angle, I'm assuming it's probably going to be radians. Let me just double check. I think it should be radians, because if we are dealing with oh, what is I don't know what it means, but I've just implemented the function. I hope, yeah, this is okay. Maybe we can actually do a little bit of a test with something that, with this example here. So if I use his example, then I should be able to at least determine that the answer is correct. And it seems like it's returning things in degrees. Oh no, yeah, he converted it from radians to degrees. No? Oh, maybe it's supposed to return in degrees. Okay, I'll figure that out later. But okay, at least we have here one example. So I'm going to copy this coordinates, and I'm going to try that here. Okay. So let's do this. So I'm going to comment out this one for now. So determine angle. So 1, 1, 2. So 1, 1, 2, and then -4, -8, and then we have 6. Okay, so this should give me the same angle that it's in that exercise, right? In that example. If it doesn't give me the same angle, then I know maybe I've done something wrong. So this is my unit test for today. I'm sure I should have more, like more examples, and just make it more. I just want to get it to work today, to be honest. Maybe I'll spend some time offline to make this presentable. Okay, let's see. System console. Oh, I didn't print it, right? So print. Run again. Oh, I need to save it because you never know when Blender is going to crash on you. Okay, so it's giving me 1.57 and it's not exactly what? But yeah, his value is in degrees, and the math one is returns things in radians. Okay, so I need to convert this value to degrees if I want to determine if it's correct or not. So radians, so math.degrees, so I can give it, I can use that for now just to see if it's correct or not. So okay, so math dot, okay, it's going to be a bit, because I don't really want to deal with degrees, to be honest, because it's I don't need it. I need the radians anyway. It's 150. Okay, so this is where I need to go back and check what I might have done. So 2 points. Oh, this is like, it's saying 361 here and then B defined as, I think it's missing. And then he has another example, like completely different points here. So the vector between point A and B, okay, I'm assuming that's what he's calculating, not the, so the initial, also the vector B, okay, so I already have the vectors, right? So yeah, I'm not sure about the example he has here. So I'm going to have to try my own examples. Yeah, I've done that anyway. Square roots, yeah. Okay, I'm going to assume I'm right. Okay, so I'm just going to try and use this. So we have an angle, and then I need to do the rotation. Okay, so determine angle. Between location start and location end. No, it's between, so the angle is going to be between the z-axis, so 0, 0, 1, and then the location end. Yeah, I think that's it, location end. So location end. And then we should be able to get the right angle. And then I can pass this in here as the angle. So the orient axis, that's probably if I want to restrict the rotation. It's optional. So for now, I'm just going to put nothing here. I'll add things that I need. Orient matrix is yeah, I'm going to remove this for now until I know what I need to add. It's too many things. Constraint axis. Yeah, so the constraint axis might be useful. So for now, I'm not going to constrain anything. Mirror equal to false, proportional size equal to 1. Okay, so almost everything out. Okay, and now save. I saved everything. Okay, I'm going to delete this one. And fingers well, obviously the first time I'm doing this, I'm not going to get the right answer, but it's a good. I should hopefully get close enough without crashing Blender. Okay, let's see what happened to my cylinder. Oh, I didn't call anything actually. So connectNeurons, I need to comment it out. And then I comment back in again. This one I don't need it. And yeah, let's do this. So play. Okay, so we have. So this is the origin, right? Where's the origin? So n. So this is currently in 0.5, 0.5, 0.5. Yeah. Okay, so we have. Okay, I've done a rotation here. So minus 54.7. That's roughly where. Not far. It's not far away. Okay, so how do I get my? Okay, so rotation Eulers, radians. So this angle. So to rotate in. Yeah, there should be two angles. Okay. Theta. So what is going on here? So value equal to angle. And then constraint axis. Right now I've made it everything false. And I need to, basically I'm trying to make this cylinder hit the coordinates in a location start and a location end. So the start has to be a location start and a location end has to be in a location end. Because when I create the cylinder, it's facing basically in the vertical. It's in the right. It's almost in the right place, in the right origin, but it's just in the wrong angle. So what I want to do, I want to rotate it so it hits the point we want it to hit. And then I use this determine angle, so because I want to, going back here, I want to, so imagine you have the Z going up, right? So the Z is the vertical axis. So I'm trying to rotate according to that axis, right? So that's the vector. Okay. I see, I'm doing it wrong, I think. Am I? Let's do it again. Okay. Don't know what happened here. So it only did the rotation. Didn't rotate anything at all. Zero 0.5, 0.5, 0.5. Yeah, this is kind of correct, actually. So there should be an angle for each. Okay, so if I go back to my drawing board, I need to make a better one because this one is not very helpful, is it? Okay, so let me just make this a bit more tiny. So for my cylinder, it has to be between 0, 0, 0 and 1, 1, 1. This is a starting point. It has to hit the origin. I think I know what's going on now. So the vector I have, so the actual coordinates where the cylinder is 0.5, 0.5, 0.5. So this is the middle of the cylinder. Yeah. So I wish I could just do a cylinder here because that would be helpful. Maybe just go to the other type of diagram. Don't know how I got this one in the first place. Oh.io. Just open a new one. New incognito window. Again, the same thing. Right. I don't want this one. More shapes. Okay, that's what I need. Okay, so I need, I need a cylinder. Just to make it easier to visualize. Okay, this looks like one. Okay, make it a little bit more narrow. Okay, so this is my cylinder. Okay, so it's 0.5, 0.5, something like this. Yeah. Midpoint here. So if I rotate this, so this is the vector, the current vector of the cylinder goes up. Okay, my vector. Okay, I think what I did wrong, I didn't work out the vector, right? So vector 1, A, is going to be (1.0). It's going to be the same coordinates for X and Y. And it's going to be 1. Okay. So this is where I'm rotating. So this is the axis, the vector itself. Yeah, and the other vector, which is where I wanted to get it to, is the, it's basically the one that's this one minus this one. So vector B. Okay. So these are the two vectors. Okay. And then if I calculate angle, then it makes more sense. Okay, so let's see here. I'm starting to. Okay, so I have here a question. Fact 1, the Enlightenment. Would it be considered a bit? Question 1, Fact 1, the Enlightenment. What? Sorry, I don't understand the question. Maybe, Sherry, maybe you can rephrase it and I'll try to answer it. Anyway. Okay, so the thing I was trying to do. Okay, so I'm going back to the code. So I have my vectors. So this one, and this one. So scripting. Okay, I have. Okay, so we have. Okay, this is the connectNeurons. Okay, and we have the determine angle. So because I'm passing in this hard coded. So for now, I'm just going to make this. Okay, where is it? The vector. I'm just going to pass in. (0.5, 0.51). Okay, and see if it helps. Is it? Okay, 0.5. Then 1. Okay, let's see what happens. I'm going to delete the one that's already there. So we have, so we press play now and see what happens. Okay. So it's different angle at least. I think this is more of an issue of the API, not so much the result. Or is it? It's not exactly. Is it correct? Let's see. So let's go to modeling. You can pick one point here. It's very close to the origin, right? And this one is where? I think this is the origin here. So it's completely wrong. Two geometry nodes. Zero. So 0, 0. Okay. So let me just go and do a little bit more investigation. So Blender. Okay, so Blender okay, so let me see. So we want to rotate. Okay. Blender. Oh, wait. I'm going to make this problem a bit simpler, just to make it easier, first of all. So I'm going to fix one of the coordinates. So instead of saying connect neurons to 1, 1, 1, I'm going to make one of these numbers 0. So I'm going to say 0, 0y. So this should be easier. And then here, so should be just on one axis, right? So instead of trying to move in the 3 coordinates at the same time, it's just going to do 1. So I get one right, and then the other one I can just fix it later. Just play this again. Scripting. So my location end is now, okay. So this is going to be the XZ plane. Okay. So I can calculate angles between these two. Why do I even? I'm going to just try like this for now. Up in there. So system console is telling me there is an error. Division error. Okay, division by 0. What did I do wrong? Location start, location end. connectNeurons. Oh, I see. So I'm dividing by 0 somewhere. Product SQRT. I'm not sure where it's coming from. The distance. So line 103. Oh yeah, determine angle. 103 here. So the product of SQRT, so XA plus YA plus ZA. Why would it be 0? So XA is 0. Okay, 0, 0, 0. Let's see. I got it. It can't be. Okay, I can't have a vector with 0, 0, 0. Makes sense. So I use the midpoint. My vector was 0.501. So if I have 0 and 1 here, so the 0 and 1. Has to be vertical. So the midpoint to print midpoint. Just going to put as much information as I can so I understand what's going on. Midpoint. System console. We have midpoint. Zero 0.5, 0, and 0.5. I need to write something down. Okay, so if I just do, for now I'm only doing 2 axes, right? So the y is 0. So t z, and then x. Yeah, we have our point. So midpoint is going to be so this is our point 1. So 1, 0, 1. Okay. Then the midpoint is 0.5. So 0.5. 0.5. Then what do we have here? So that's small, tiny. So this is the midpoint. Yeah, and this is where we have our cylinder. Yeah. Make it as thin as possible. So our cylinder is here. Yeah. And it already should have the right dimensions. It should already be at the right midpoint. And we want to rotate this like this. Yeah. Okay, so it has to be a rotation on the Z x-axis. So it's going to be a rotation around so the rotation is, oh, I see. So the vector for rotation in this case, it has to be on this direction, right? So it has to go past, well, this is not very good, easy to see, but it has to go transversal. So it has to be, it's like, it's like y equal to, is y equal to 0.5. No, this is y, right? And y is 0 at the moment. Okay, so we have here, so this is y, yeah, and y we've decided, okay, to make it simple, it'll be 0, but then the vector still needs to go through the y plane, right? So the rotation vector. Oh, it's the x. No, it's rotating around the y-axis. Yeah. So rotation is going to be, so my vector in this case would be so 0, so it'll be like something like 0.5, then 1, and then 0.5. Here's the vector, I think. So it's like y and, okay. Yeah, I think I'm getting there. Just trying to remember some of the vector. Which numbers? So rotation to D. Z-axis. Yeah, I remember this. Okay. I think I've done this before. I'm just going to cop out Blender 3D from 2D to 3D. I'm pretty sure I have these functions already somewhere. NumPy. Just have to remember. So rotate this angle. Yeah, maybe it's not here. Rotation. Thank you. Rotation attribution. Rotation around arbitrary vector. That's what I'm trying to do. The Rodriguez formula. I remember this one. We have to. Yeah, the Rodriguez formula. Yeah. So I'm going to go into my GitHub project because I've done this before. 1 second, I need to open. For 3D. So. And I think I even got the formula out of what? Okay, so we find Rodriguez. So angle. I'm pretty sure I had it somewhere. Rodriguez formula. Okay, 1 second. It was for so where's the code? I'm trying to remember where the code is. I'm sure I have more than this. Blender. Rodriguez. Repositories. I'm not going to give up, am I? Until I get this done. But I know that Blender has this as well. That's the rotation. I think I implemented the rotation, but right now what I want to know is the angle, not so much how to do the rotation, right? So, but I think surely that's the one. 5.5. Yeah, this is it. Application end. Okay. So what's wrong with this? So 0. Yeah, sorry, I'm a bit silenced now, but it's just trying to focus on this. Okay, I think I'm close. Though I think there's something wrong with close. If I just rotate it and so Z, so around Y, like this, right? That's it. And 0.5, 0.5. So that's the arc, the sine of the two vectors. It should be at different angles, right? We still have part one. Special to okay. What's this? And then we have to rotate across the other angle. So it's two angles. So angle one. Okay, so it's not just one angle, it's more than one angle. That's I think what I got confused by. Right? So to determine this time, so it's easier. Point. So I want to have this vector. So I have this do it this one. To calculate this angle, right? So this is a triangle. And then there's another angle. Just this one. I can create. I can calculate either one, right? The same. So for the simple case where our cylinder is already in the right plane, it's already we're fixing one of, we're only doing this in 2D, so it's fairly easy to do this, right? I should have to just calculate the difference between this vector, no, the angle between this vector and this vector, right? And this is a triangle, and I can, there's formulas for that, right? So it's like a Pythagoras theorem or something. As long as I know, of course, I need to know the distance between this one and this, so it needs to be, yeah. So I know this. So I know, oh. In this case, X. I'm going to make it simple. Okay, let's do this just for X and Y. No, this is 0 actually. So 0Y. This is 1, 0. Okay. So to get, so this is 1. Basically, here the distance. I can give these basically letters, right? But it can be something like A, then B, and then C. And I think if we apply the angles equation, I think I remember something. A equal to something like, yeah, there's a formula for that. A equal to, yeah, I forgot the exact yeah. So this formula would help me calculate angles. Oh gosh, it's like it's not easy. It's not as easy as I thought it was. In the first case, the angles of triangles are then. Yes, simple, very simple. So what is this one? This is me saying very simple. Okay, thank you for that. I remember this formula. It's not simple as we can see from this huge matrix. But it's, as I suspected, it's not just a case of rotating. You can't just get one angle, you get 3 angles, right? I need to go back to this. Wikipedia. Right, so a rotation about the origin is represented by 4 real numbers a, b, c, and d, such that a, b, c plus d equal to 1. Oh, I see. Any center rotation in 3 dimensions is uniquely determined by its axis of rotation and the rotation angle. So it's a unit vector, which is kind of similar to what we're trying to solve. A, B, C, and D. And we have so I've once implemented a rotation method, right, using that formula in Stackoverflow to rotate something, but I knew how much I had to rotate it for, and it was for a similar reason, because I wanted the start and the end to match what the points I wanted it to match to. But now this angle, so this is like it's part of the Euler. So I have the end coordinates, so I know where it's supposed to end, right? Turn. Oh, okay. So axis and theta. So this is the angle that we want to find out actually. So we want the opposite. So we know where this is supposed to end. So I think I'm quite close. Zero point 0.32. So I guess I deleted too many arguments. So rotate, value, orient axis. This is another way to rotate the object. Okay. see. Mm. It's actually the value I got. So I was almost there. What did I do wrong? I didn't rotate around the right place, is it? Okay, so I think I'm getting closer to the answer. So a vector needs to be, I'm going to use 3 vectors. So I want it to be facing here, right? So I'm going to use 3 vectors. One in the z-axis, like vertical. Another one horizontal. The other one, yes, sideways. So I can work out the 3 angles. Yeah. Not sure whether that. Yeah, I think that makes more sense. So determine angle. So vector A. So this is going to be, so the midpoint is this is where it needs to. Yeah, the midpoint should be enough. So let's do this. So rotate. So Z. So if I want to rotate around the Z axis, I need to wait. Yeah. So the vector should be there's no rotation around the Z axis, right? So 0 in the Z axis actually. See that on the X or the Y? This is going to be angle. Okay. So we have rotate. I'm not sure if this is going to work. It's a bit late now. I probably have to go back to my maths classes. Right, so distance between rotate x vector. Okay, let's see. So we need to calculate determine angle. So my idea is vector and then the other one is going to be the cylinder, right? So I know the cylinder is always facing up, so it's always going to be it's going to be like this. In a way, I don't think there's any point to I know it's facing up anyway. So I'm going to call it angle X. I don't know if it's X or not, but never mind. So angle X, then angle Y. I don't think there is a angle Z, so I'm not going to do that. So rotate Y vector. Okay, and then I specify angle X and angle Y. For now, I don't do anything here. I'm not sure whether this is going to work, but you know. Let's do it. There's an error. Y95. To determine angle. Okay. Sure whether this is like numpy. Let's just see. Print, rotate, Z vector. Okay, it's not doing what I was hoping it would do. Okay, so let me just fix that. Midpoint. It's okay, 0. And so Z. Mid. Um, yes, please bring it on. Yes, definitely. But I'm trying to, yeah. Undo. Yeah, let's do this. Too many values expected. Oh yeah, still have this one. Oh yeah, this one here. Okay, right. I think I might be getting there actually. So I'm just going to. Ooh, no. I think I'm getting close. This is just like, wow. This, let me see the coordinates of this. It's very close. It's the wrong direction. So it's plus 58. There is definitely a z-axis rotation that I was trying to ignore. But if I don't do any rotation, right? Just like this. So it should just be X and Y. But this is not. It's this. I don't even know what's the actual axis on this, to be honest. I'm assuming it's here, but it might not even be there. Just find. I have to remove some spam from the channel. Okay. Right, so let me just for 0. Okay, yeah. It is okay. It is correct. 0.5. Rotation is around here. Oh yeah, okay. Thanks for the search. Yeah, that's useful. Hopefully it will allow me to go to bed. I sometimes I just take things on and don't even. Anyway, this is why I'm doing it. See what are the. Yeah, this is it. Thank you. I think that's actually very similar to what I'm trying to do. Let's see what it says. So he wants between 2 points. He's using the rotation here. So location 1 and location 2. I'm going to copy this. Let's try and adapt this code and hopefully this. I'm not going to throw away all my code because I think it's still beautiful, but it doesn't work. Or it... So let me see. So this is positions. This is the vector that we. So P2 minus P1. The magnitude. So if x equal to 0, I think it's doing some conditional stuff here. Okay. Beta and theta. Oh, honestly, I can just copy and paste this for now. Paste it here. Maybe just create a new method. Comment it out. connectNeurons. Location start. Location end. Then we have this. So we have I'm going to call I'm going to make patience and patient start. Then we have location end minus location start. Same here. We have square root because we don't really need the z, right? The z is the same. Okay. X equal to 0. So I just need to replace this with my primitive cylinder. It's using a scale here, I think. So I'm going to do depth equal to 1 for now. Location equal to I'm not even going to put location. I'm just going to copy this as is. And then gap equal to P2 minus P1. Location. And minus location start. And then we have physical cylinder or something. Let's just do that. No. Scale. Location start. Then location. End. I probably should have just changed this to, never mind. So, okay. Let's see what happens. Windows errors. We have empty one is not defined. What is empty one? Empty one. Where? Could be empty one somewhere. I don't know why this search doesn't just empty here. Yeah, I need to check the line numbers. Line 110. Oh yeah, because I put it here. Okay. We have connectNeurons is not defined. connectNeurons. Location start has an uppercase N. Another one. Location start is not defined. That's a line 132. Here. Another one. SQRT is not defined. What is this? Okay, math.sqrt. Another one. ATAN is not defined. So math.ATAN. Math.ATAN. Antivirus. ATAN is not defined again. Line 139. 39. Yeah, here. It's one more. Unsupported operand type for tuple and tuple. 149. dot magnitude. Oh, this is where copying code. P2 minus P1, okay. Mag, right? Yeah, so I think that's what it is anyway. So mag. Did I just go to another script? Here. It went to another script for some reason. Okay, so here. All right, yeah, I was lost. So magnitude is where? Yeah, here. So I should be able to just say mag. Right? $155. Being honest, like I'm not using numpys, that's why it's d1.location. .array. I is not defined, 159. Okay, math.py. Okay, so let's do this. Oh, no error. Okay, so let's see what happened. Getting closer. Let me just do it the previous one, so I'm not sure. Okay. And again, so connect neurons 0 to 1. And then it's getting there. Definitely, I think it's the right angle now. Just the only thing that's wrong is the origin. Maybe the depth is wrong. How did I calculate that? So which one did you say it's not? It's an object? Yeah. So I think this location. I think the thing that's going wrong is here. The scale. But I think I had worked that out correctly before, so I can just make this a midpoint. Yeah, that's what I did here anyway. Midpoint is yeah. Okay. And what does that mean anyway? Oh, I see. So you're saying I should just use the same thing, exactly the same thing. Okay, let me see. So empty, but there's no empty objects in my scene, unless, yeah. I think they should matter. I think it's almost there, you know. It's just that it's what's wrong here. It seems to me it's more to do with how big it is. Oh, I see. So that's what you mean. The magnitude, is that what? Okay, got it. Okay. So because he's assuming. Okay, but we already can get the. I think we can do the same. So I think this form is very good. Thank you so much for that. And I'm just going to adapt it to take into account my formula anyway. So depth equal to can be the same as I had before. So distance, it's the magnitude, yeah. So depth can be mag. So mag is the distance between a location and a location. Okay, this is different actually, you see. I'm just going to call that distance. Distance. Okay, and then I just put this maybe here. See if that works. Oh, I see. Mag. Okay, so he's using mag, but maybe you should use distance. Let's replace for the time being equal to dist. 1153. This one. Let me just undo this so I go back to. When 153 in this code, okay. 153 in this code. I don't see. I mean this one. P2 minus P1 dot magnitude, yeah. Well, but these objects, they don't exist, right? If I run this here, okay. Yeah, there's no such empty. So gap is let's see what's actually wrong. It's actually on the right location. It's actually modeling. Not quite. Oh, okay, so it's actually halfway through. So it's supposed to go from 0 to 1, but it's going to... Yeah, but I'm not trying to connect to objects. Yeah, I know what you mean. Like if I had a neuron, I could use that. But in this case, so 0.5. More than 0.5. So the origin is here. Oh, but that's the origin of... Yeah, I see what you mean. Yeah, which is the same as the distance I had, right? It's the same as this. Nodes. 15. Try again. Oh, okay. Slightly. Yeah, I wanted to show the axis is easier. Number 0.7. That axis. I just want so it's actually just doing I need to remove this. And then the rotation seems fine. It's just the depth. I see. It's just okay. Yay! I think I'm. Yeah. I think this might be it. So let me just see. Took a long time. So I'm very close. So this should be around close to 0. But of course we are around. Yeah, I think it is. I think we got it, right? Maybe it's just stretching this a little bit more. Don't know why it would be just short. very close. Yeah, thank you for your help. It's not as easy as I thought it would be. But no, I think there is something. No, yeah, it's not supposed to be. Okay. That I don't think it's 100% right yet. But you know, maybe I should just take that as a win for now. It should be like 1 here. Oh, wait. Patient start. So 0 to 1. There's something here that's still. I'm going to just check this, but I don't think it makes any sense to do that. Doing. Have now. Maybe the. Just why is it still just pitch? Your question is, how do I get like the same? I can provide this script, yeah, as a gist, and then you can continue. Definitely, I can provide that as a gist, yeah. I'm still thinking like, okay, something is wrong here. It's not exactly hitting the coordinates I want, but I think I'm going to call it a day. I didn't achieve it exactly as much as I planned to, but you know, it's too late already. All right. Thank you so much for joining the live stream, and yeah, I'll see you again next one. I'm definitely going to continue this because I won't give up until I get this massive neural network visualized in Blender. And I'll see you again soon. Happy coding.